Hi everybody. In this video we are going to discuss about how we can perform delete at the beginning in a circular linked list. So first let us consider a circular linked list with 5 nodes like this, and when I tell I want to perform deletion at the beginning, the input of this operation is the list in which I am going to perform the deletion, and I expect the element that is deleted to be returned. So the first element in this list is 10, so this operation should return 10. Okay, and how we can do this? Let me have a temporary pointer and initialize that to the first node of the linked list, and we have to move the temp to the last node, right? The second step will be to move temp to the last node, and you have to make the next part of the temp now. That is, the last node's next part should contain the address of the first node, isn't it? Now the first node is going to be removed, so the next part of temp should contain the address of the second node. This change we have to make, and we have to make head to point to the second node, and this memory should be given back. Okay, because this memory is dynamically allocated using malloc, so it's a good practice that we have to give it back using free. So let me store the address in temp1 because this temp has already moved here. Right, so let me store the address of the first node in temp1, and I'll be storing the data in D, and then I'll be telling free. Okay, maybe I'll be slightly changing the order of the steps so that I'm not losing anything, but this is the concept behind doing a delete at the beginning, right? Two corner cases we have to discuss. The first one is going to be when the list is empty, right? If the list is empty, then what we should do? Deletion cannot be performed. So you have to indicate the failure and return some dummy value, let it be -1. And the second case that we have to consider is when there is only one node in the circular linked list. So if there is only one node, for example, only 10 is present, how the linked list will be looking like? It will be looking like this. Okay, one node with the next part containing the address of itself, and the head will be here. This is how it will be looking like. Okay, now if you apply the same algorithm, the algorithm tells that you should have a temporary pointer, temp pointing to the first node, right, and move to the last node. But when you look at a circular linked list with only one node, that is the first node and that is the last node as well. Okay, so temp will be here, and as per the algorithm we should store the address of the second node. Where is the address of the second node? Address of the second node is in the next part of the head, right? We have to store that. What will happen is, once again the same address will be stored, and this algorithm will not work for the case when we have got only one node, right? So we have to treat it as a special case, and we have to make head also as null, because when there is only one node, if you perform deletion, after that the list will be empty. We indicate empty list by head equal to null. So that should be properly done. Let us formally write the algorithm. So the input of the operation is the list, and if the list is empty, you are going to indicate failure and return -1, and you are storing the data part of head in data, a variable, and you are checking if there is only one node in the list. If there is only one node, then what should we do? We should free the memory pointed by head, make head as null, and you have to return the data. Otherwise you are going to create a temporary pointer and initialize that to head and move the temporary pointer to the last node, and after this we have to make the next part of the last node to contain the address of the second node, right? And you have to make temp1 to contain the address of the first node, and we have to move head to the next node. Okay, you free the memory which is being pointed by temp1 and return the data. These are all the steps that we have to follow. Let us implement in C++ now. Okay, so in the header file already we have declared we have to have only list as the argument. Since this is object oriented programming, the function by itself will be called through a list only, so we will not pass anything. And this is the CPP file. I have just copied the algorithm here as a comment, right? So let us do the implementation step by step. That is enough, right? The last thing will be to return the data. Okay, so the first step is we have to check, but before that let me finish the declarations required. First thing is for temp, and I need temp1 also. I need an integer for storing the data. Okay. So in the algorithm, what we tell, if the list is empty, right? So if is empty, what should we do? We should indicate the failure. How we will indicate? Deletion error flag equal to 1, right? We should, if you are using deletion error flag, that is the global error flag here, we should reset it at the entry point of the function. That is important, right? So we will make this as 1, and you return a dummy value because there is a return type of the function. So we should return, let me return -1, right? And you're going to proceed, and you're going to tell data equal to data part of the head, right? So head data, we can tell like this. And you're in the step number 3, what we are doing, we are checking if there is only one node in the list. How can I check that? You can tell if head equal to, right, head next, right? If head equal to head next, then we can understand that there is only one node. And what are the things that we have to do? We have to free the memory pointed by head. So in C++, new and delete are the operators that we will use for dynamic memory allocation and deallocation. So let me tell delete head, and head equal to null, and then we have to return data. Okay, done. And in step number 3, what we are going to do? We are going to make temp to point to the head, right? So temp equal to head. Temp equal to head, and move temp to the last node. So how will we know we are in the last node? When temp next is equal to head, right? So when temp next equal to head, we will know that we are in the last node. And yeah, what we should do now? Okay, last node, if I have to move, then I have to tell temp equal to temp next. While I am not in the last node, I am moving my temporary pointer to the next nodes. If I am in the last node, what should I do? I must make the next part of temp, right? So temp next will be equal to head next. Okay, temp next is equal to head next, and then you're telling temp1 equal to head, right? We have to store it, and we have to move head to the next node. Yeah, we have to move head to the next node. So we can tell head equal to head next. We have to tell head equal to head next, and you have to free the piece of memory that is pointed by temp1. So delete, okay, temp1 we have to make, and then you return the data, right? So return data. Okay, so these are all the steps that we have to follow. Okay, let's compile and see. And before compilation, I will just show the application file. What I have done, I have made the call to the delete beginning function, and after the function call, I am checking if the error flag is set. If the error flag is set, then I am going to print deletion failed. Otherwise, I am going to tell the element which is getting deleted, right? One more thing, when I set the deletion flag, error flag, boolean is available in C++, right? So you can tell here false and true. Yeah. Okay, it's better to tell us true and false. Now let us go to the terminal, and I am going to compile it. I have written a shell script. Let us use that. So what you see here in the file cll.cpp, when we are using script to compile, we should be more careful while we are looking at the error. In which file it is occurring also we should see, right? So let me go to line number 120 in this file cll.cpp, right? I have put capital N for next. That's a typo. So let us compile it. It's fine. Let us execute it. Now let's check what is getting done, right? Actually you have 10, 7, 15, all are insert end, right? So what will happen is when you are using like this, 10 will be here, and then 7, 15, 28, all are insert end, and then you have got 19 and then 25 at the position 2, right? So after 10 I'll be having 25. This is the order of the elements. Now I am telling delete beginning, so 10 should be logically removed, right? Let us see the terminal. Yeah, 10 is not there, right? 10 is not there. You have got 25 as the first element, 25, 7, 15, 28, 19, right? And we are seeing a 0. Why that 0 is getting printed, right? We have to check that. Why 0 is getting printed should be checked. 1 minute. So this is the place of error. Instead of telling that while temp next not equal to head, I have put as while temp next equal to head, right? This is the problem. Now we should change this as while temp next not equal to head. I have to move the temporary pointer so that I will be reaching the last node. My temp will be pointing the last node. Okay, so let us compile the code and run it again. Now that 0 is not coming. Actually we want the elements to be as we have written 25, 7, 15, 28, 19. Okay, and we will check the corner cases also. So in my application file I will go and comment all except one, right? So I will comment all insertions except one, so that I'll be checking the condition when there is only one node, right? Let me go and compile and check. Yeah, so element deleted is 10. You're not seeing anything getting printed, isn't it? Because the list has become empty. And if I am going to comment this line also, then I am trying to delete in a empty list, right? So in this case you will see the deletion fail has been printed. Okay, so I'll be pushing the code in the GitHub. You can try it by yourself. Thank you.